The last thing we're going to talk about with a confidence interval is how to interpret them. When we talk about a confidence interval, remember that we find confidence interval when we don't know the true parameter. So we're going to use some sample data to see if we get plausible values about that particular parameter. The thing we need to understand is that when we talk about confidence intervals, when we talk about the lower and upper limit of those plausible values, is that we're going to use the sample to infer about the population. So the sample is always going to be what you're talking about, but what you're really looking for is a population value. And when we try to interpret this, we want to talk in terms of population terms. We want to talk about parameters or true values. So here's an example of how we interpret a confidence interval. In this example, it says to identify which is the correct interpretation of the confidence interval for the given situation. And here's the situation. A biologist has taken a random sample of a specific type of fish from a large lake. A 95% confidence interval was calculated to be 5.6 and 8 pounds. So your lower limit is 5.6 and your upper limit is 8 pounds. You have 4 different choices. Only one of these is correct. It's a multiple choice problem. So let's look at the questions and try to eliminate which ones aren't right and try to figure out which one is right. The first one says that 95% of all the fish in the lake weigh between 5.6 and 8 pounds. Well, let's talk about again what a confidence interval does. It wants to estimate the population value from the sample. Look at A and see if we're doing that. This says that 95% of all the fish in the lake weigh between 5.6 and 8 pounds. Is this taking a sample and trying to estimate the population from it? No. What it's actually saying is that if we had 100 fish in this lake, let's make it simple. We had 100 fish in this lake, 95 of them would have weights in between 5.6 and 8 pounds. That's not what we're interested in at all. We're actually interested in the mean weight of the fish altogether. This is saying that each individual fish is in there. So that's not going to actually cut what we want to do. So this first answer, A, is not correct. B says, in repeated sampling, and this is kind of word you want to look for. You want to look for in repeated sampling, because that means that you're looking at more than one sample and you're taking these samples trying to make estimates about it. So in repeated sampling, 95% of the sample means will fall within 5.6 and 8 pounds. What makes this answer wrong now is this, again, you're going from the sample to the population. This is explicitly talking about the sample means. And we're not using this, we don't care about the sample means. The only reason we need sample means is because we need an estimate for the population. So this is taking the sample to reference the sample again, which makes this answer not correct. C says in repeated sampling, so you have that word in repeated sampling again. It means you're looking at more than one sample. 95% of the time, the true population mean of fish weight will fall between 5.6 and 8 pounds. And again, now, this one talks about a sample in repeated sampling, and then you're going to talk about, you're referencing the population. Because you have the word true population. You want to look for that wordage there. So C is a correct answer. Look at D. We're 95% confident, and again, you can see things like this too. 95% confident, that's kind of wording you want to look for, that all the fish weights will fall between 5.6 and 8 pounds. Well, now they're telling me that I'm really only interested in the population mean. They're talking about all fish. So this tells me that all the fish have to have a 5.6 and 8 pounds and have to fall between 5.6 and 8 pounds. Is that necessarily true? If you think about it, if you look in the lake, will all the fish fall in between 5.6 and 8 pounds? No. You'll have some that are actually smaller than that, some that are actually bigger than 8. But when you average them together, they should fall in between these two values. That's what the actual confidence interval is saying. This is actually saying that all the fish have to fall in between 5.6 and 8. This is also wrong.